Theoretical recap. An Ethernet frame is the fundamental unit of data at Layer 2, data link, of the OSI model. When two devices communicate on a local network, data is broken down into frames before being transmitted over the physical medium. Each Ethernet frame follows a strict structure: a preamble, 7 bytes, used for synchronization, a start frame delimiter or SFD, 1 byte, a destination MAC address, 6 bytes, a source MAC address, 6 bytes, an ether type/length field, 2 bytes, indicating which Layer 3 protocol is encapsulated. For example, 0 by 0800 for IPv4, 0 by 0806 for ARP, 0 by 86DD for IPv6, a payload, 46 to 1500 bytes, containing the actual data passed down from upper layers, and a frame check sequence or FCS, 4 bytes, used for error detection via CRC. A common mistake beginners make is confusing MAC addresses with IP addresses. MAC addresses are hardware identifiers burned into network interface cards and operate at Layer 2. They are used for local delivery only. IP addresses operate at Layer 3 and handle routing between networks. Another frequent error is overlooking the ether type field, which is the key to understanding what protocol lives inside the payload. Mini example: if you capture a frame with ether type 0 by 0800, you know the payload contains an IPv4 packet. If you then look inside that packet, you might find a TCP segment, and inside that segment, an HTTP request. This is encapsulation in action. Each layer wraps the one above it. Wireshark makes this layered structure visible by color-coding and expanding each header field individually. Workshop brief. This workshop puts into practice what you have studied in the Layer 2 data link chapter and the OSI model introduction. You will work with a real packet capture file, PCAP format, and use Wireshark to read, dissect, and interpret raw Ethernet frames. The goal is not just to open a file and click around. You are expected to demonstrate that you understand what each field means, why it matters, and what it tells you about the network conversation taking place. Your first task is to install Wireshark if you have not already done so, and to obtain a PCAP file. You can either capture live traffic on your own machine, even a few seconds of browsing will do, or download a sample PCAP from a reputable public repository such as the Wireshark Sample Captures page or packetlife.net. Once you have your capture file open in Wireshark, begin by identifying at minimum 5 distinct Ethernet frames in the capture. For each frame, locate and note down the destination MAC address, the source MAC address, and the ether type value. Use Wireshark's frame detail panel to expand the Ethernet 2 header and verify that you are reading the correct fields. Your second task is to go deeper. For at least 3 of the 5 frames, follow the encapsulation chain. Identify what Layer 3 protocol is carried in the payload, IPv4, IPv6, ARP, etc., and if applicable, what Layer 4 protocol is nested inside, TCP, UDP, ICMP. Document this layer-by-layer breakdown clearly in your deliverable. Pay close attention to RP frames if they appear in your capture. They are a special case where there is no IP header inside, and understanding why will reinforce your grasp of the role MAC addresses play in local network resolution. Your third task is analytical. Choose one frame that carries an actual application layer exchange, for example, an HTTP request or a DNS query if available in your capture. Trace the full encapsulation stack from Ethernet down to the application payload. Explain in your own words what each layer header contributes to the delivery of that data. If you cannot find such a frame in your initial capture, do a short browser session while Wireshark is running and capture the traffic yourself. This part of the exercise is designed to test your reflective understanding, not just your ability to read a UI. Finally, prepare a written deliverable. It should include a short introduction explaining where your PK file came from and how you captured or obtained it, a table or structured list documenting the 5 frames with their Ethernet fields, the encapsulation breakdowns for your 3 selected frames, and your written analysis of the full stack frame. Be precise and concise. Avoid copy-pasting raw Wireshark output without explanation. Your commentary is what will be evaluated. You are allowed to consult all previous course materials and any internet resources you find useful. You may also ask for help or work with a peer, but the written analysis must reflect your own understanding. This workshop is designed to take approximately 3 hours. Allocate roughly 30 minutes to setup and capture, 1 hour to frame identification and documentation, and 90 minutes to the analytical section and writing your deliverable. Submit your completed work before the deadline expires. Late submissions will not be accepted.